Okay. Get a smart page open. There it is. Alright, the first, and I worked through this morning, so got notes on the notebook paper because there wasn't a lot of room on that. So on the first few there, I wanted us to write an equation in slope-intercept form. So first thing we had to remember was even what slope-intercept form was. Okay, slope-intercept form is your y equals mx plus b. So my final equations for number 1, 2, and 3 need to be in that form. That's what the directions said. Now, I can kind of go straight there because these show me where they hit the y-axis at, but I went ahead and found the slopes on them to make sure. So I had to know how to find the slopes. To find the slopes, and a lot of people have this backwards. You subtract your y's and put that on top, subtract your x's and put that on bottom. I saw a lot of people putting the x's on top. Y's go on top on the slope. And then once I get a slope, I'm going to use a point off that graph, and I'm going to go into point slope form. So we wrote all of that down in the first week of school, and I got to use all three of those to do numbers 1, 2, and 3. All right, number 1, I had the points 10, 1300, and 2800. So to find the slope, I subtracted my y's, 1300, and you put them in either order as long as you're consistent, minus 800, over, subtract my x's. Since the 1300 is first, I got to put the 10 first. So that ends up getting me 500 over negative 10, which is negative 50. So there's my slope. Now it should make sense to you that the slope's negative because that line's going downhill from left to right, right? Okay, so now I've got a slope that's going to plug in that M spot. I just need to pick which one of these points I want to use. Anybody got a favorite one? The 10 one or the 20 one? 21 would be y minus 800, right? Equals M times x minus 20. See how we plug those in the y and the x spot? Now to get that to slope-intercept form, what do I need to do? Distribute that negative 50, so I'd have y minus 800 equals negative 50x plus, what's 50 times 20? You know 5 times 10, add your zeros. 1,000, out of the way. That shouldn't be a difficult one. Negative times negative made it a positive on that. Alright, now my last step to get the y by itself, to get the slope-intercept form, I need to get rid of this minus 800. Add 800 into its like term on the other side. So we should end up with y equals negative 50x plus 1,800.
I did it a different way, but I got the same thing.
Yeah. When I worked it on my paper, I used the other point, and I still got the same answer.
I used a different point, but I did instead of that, I just plugged it in 800 equals negative 50 times 20 plus b.
Yeah, solve for b. Yeah.
Can you do it that way?
Yeah, you can. You can. That's okay. What Macy's talking about, she plugged the y and the x and the m into slope-intercept form and solved for b instead of doing the distribute. It works either way. Okay. All right. Everybody feel like you could do one of those now? Okay. Do we need to look at the next two, or yes, no, maybe?
You can give us the answers.
Yeah. Yeah. For the equation on number 2, and if you didn't get it right, we want to look at it, we can. I got y equals 5x plus 20. Should I get that right on number 2? Anybody want me to do it? I don't mind. Okay. For number 3, that one was a weird one because it was a horizontal line. What kind of slope does a horizontal line have? 0. It's undefined on a vertical, David. Way to remind us of that. A horizontal line has a 0 slope. So that means there's not going to be 0 times x is nothing. So there's not going to be anything in the x there. It's just going to be y equals however high it is. How high is that line? 6. So it would just be y equals 6 for that one.
Would it be wrong if you said
No, you could put y equals 0x plus 6, but you're not, if that was on the ACT, you wouldn't see that choice.
What if your slope was 0 over 12?
That's the same thing as 0x, so you would have y equals 0 over 12x plus 6. That's the same thing.
Okay.
It's the same thing. Both of these simplify to the way I wrote it. Okay? They're the same thing. They simplify to the way I wrote it. Alright, so could you get 1, 2, and 3 right if you saw something like that on the test? Do you need me to do any more of those? Alright, 4 and 5. Remember, you got to mark 6 and 7 out. So on 4, and both of these were kind of friendly to me. I got to skip some stuff on them. Let me write the equations. X plus y plus 3z equals negative 4. Negative x minus y minus 2z equals 5. 2x minus z. See, that one doesn't have a y in it. Did y'all catch that? Alright, so since that one didn't have a y, I chose in the other two to also eliminate the y's. So that would save me a step. So on the other two, let me write those down. X plus y plus 3z equals negative 4. Negative x minus y minus 2z equals 5. So this ended up being a 2-for-1 special, didn't it? Because when I go, those y's have different signs. When I go to add those, look what happens to the x. They cancel out as well. X plus negative x is nothing. Y plus negative y is nothing. 3z plus negative 2z is 1z. And negative 4 plus 5 is 1. So I got a 2-for-1 special, and I already know one of my variables. Even better, I don't have to make a new equation to plug it into, because I can plug it into this third one to find the x out, can't I? So it gives me 2x minus 1, because my z is 1, equals negative 3. That's a middle school equation there. What do I do first to solve that, dude?
Add 1.
Add 1. So 2x is negative 2. And then last step. So x is negative 1. Okay. Now I do need to take those two back to one of the original ones to find my y. So when I did it on my paper, I chose the first one. Either one, first or second, is fine, but by all means, do not choose the third one. If you're trying to solve for y, the third one doesn't have a y in it. That would be useless, right? So first or second one, anybody care? First, x plus y plus 3z equals negative 4. So it's negative 1 plus y plus 3 equals negative 4. Your negative 1 and your 3 give you a 2. And then you got one step to solve that. So y would be negative 6. So x, y, z. Too bad there weren't any that had those many shortcut steps on that homework assignment the other day. Did you get that right? Did anybody try that one? Did you get it right?
I got it right.
Good.
No, that was good. 5, 6, or 7.
Well, you didn't have to do 6 or 7, but we'll do 5. We'll look at 5. Page on the notes here.
It was going to be the easiest on the test, but really the ones that you can actually like solve, like you don't have to remember anything. Like the other ones, if you're doing relations, you know, it's usually well.
That's
It's
true.
easy, just there's a way to solve them.
Alright. When I worked this one this morning, let me see what I got rid of. I got rid of the X's. Okay, Kevin did. Why does anybody else do it? So y'all don't really care. Kevin, I'm going to do X's. Doesn't matter. See, I put these two together first since they both already had the 2 X's. So I had negative 2x plus y plus 2z equals 3. 2x plus y plus 3z equals 8. My x's are different signs, so that was an addition problem. So negative 2x plus 2x is nothing. Y plus y is 2y. 2z plus 3z would be 5z. And 3 plus 8 was 11. Okay, then, let's see, multiply the first one by 2. Let's see which one I put that with, the second one, I bet. Yep. So I got my second one here. I'm just going to go ahead and rewrite it. Negative 2x plus y plus 2z equals 3. And then I multiplied this one all by 2. So I've got 2x minus 6y minus 2z equals negative 18. Oh, I think this one's going to have a 2 for 1, isn't it? 2x's are different signs, so I add. Negative 2x plus 2x is nothing. Y plus negative 6y would be negative 5y. 2z plus negative 2z is also nothing. And then 3 plus negative 18 is negative 15. So we got rid of 2 variables in that one. So now I can solve this for y. Y is 3. Now I'm going to take that, plug it in there, and figure my z out. 2 times y, which is 3, plus 5z is 11. So 6 plus 5z is 11. Subtract your 6. 5z is 5. So z is 1. You both got some good job. Okay, now I just need my x. So I would probably use the first equation since it's got a 1x. Let me write it down here real low and then I'll scoot it up so everybody can see it. I know I'm at the bottom. Alright, there's my equation number 1 that I'm going to plug into x minus 3 times y, which is 3, minus z, which is 1, equals negative 9. So negative 3 times 3 makes that x minus 9 minus 1. And negative 9 minus 1 is negative 10. So just add your 10. X is 1. X, Y, Z. It's your 131 defense. I don't like the 131. It leaves too many holes. And y'all run that, don't you?
I love 131.
Too many holes. Pick a 131 apart like a locksmith.
It's fun to play on defense, but
Alrighty. I think you're gonna kind of be a little bit relieved on 8, 9, 10 when I can shed some light on those. Those were the ones that most people all day were confused the most on, asked the most questions, but they're not that bad. Okay, it's just understanding the way that stuff is written there is a little bit different. So let's look at number 8. First off, you're matching the transformation with, you got to know what the parent function would look like first. And it tells you up there, your parent function is f of x equals x, which is just your line. That's the linear. Remember on our chart, you'd be in the linear column on that. And that, I'm going to write y equals x, means the same thing. That would have a y-intercept of 0 and a slope of 1. So it would that's your basic parent function of something linear. Okay, it would just look like that, right? Okay, now, what I noticed on number 8, it says g of x equals negative f of x plus 3. So it's at plus 3. So it had to take this thing and scoot it up 3. So it's got to be going through, it's got to have a y-intercept of 3. I did my matching A, B, and C all based on that. I looked for the one that had a y-intercept of 3. On number 8 it was C, right? See how C goes through 3 up there? Now the other part of it that you were confused on, it says then write a rule for G. Okay, all this means negative f of x. Remember, this is f of x. I wrote a y there. I guess I should have done that. F of x equals x. So I've got to take that and plug it in and do what it says. So my rule is going to be g of x equals negative, and instead of f of x, I'm just going to put what f of x is. That's it. That's the equation. Everybody see that? It said negative f of x. So I put negative. What is f of x? It's x. And they told us that in the directions, right?
I thought we had to write what it did. It already did it.
Well, it gave you g of x in terms of f. You had to plug to change that. You got to get the f of x out of there.
That was it.
F of x is the same as x, so I just plugged an x in for f of x. It was that easy. You got-
Basically, you just move the f left and
Well, I substitute. Substitute. F of x equals x. So here's f of x, so I put an x in that spot. Substitution.
so if I wrote like what it did, that was the answer.
Well, it scooted up 3 and it reflected over the x-axis would be what it actually did based on all that stuff. But that wasn't what it was.
That wasn't
Right. When it said, and somebody asked me this later in the day, when it says write a rule, that just means the equation. So that's what we were,
I thought it meant what
yeah,
it did.
that was confusing. I understand that. It's not a big
Can
deal.
we do like another one of those?
Yeah, we're going to do all 3 of those in that section.
Is that how it's going to be on the test tomorrow? or
Pretty
will it be
sure.
where we can say what happened?
I'm pretty sure it'd be just like that. All right, let's look at number 9. Let me get my graph paper again.
Is your test worded
Is it what now?
like a word test?
It is, this is chapter 1 test B. Yours is going to be chapter 1 test A.
Oh, okay.
So it's going to be like this.
I was picturing one more.
Till life shut down. There won't be any, like the whole company, you won't have any English or math till life test this year. They went out of business.
Really?
Yeah.
Really?
Made the
Yeah,
big battle then.
because we
What did you
changed, no, for real, because we changed to ACT, and ACT has, they offer like little tests throughout the year, and so all schools are taking those instead of TLI, so they couldn't stay in business. Yeah, but, so
But
we'll
now we
have,
have
we'll have a
ACT
couple of
ones, so-
ACT tests in the middle of the year instead of TLI, but that'll be good, because that'll tell us.
That's good that they
Yeah.
actually switched that to a test that's actually going to benefit us and like,
Work.
yeah, whatever that is.
Okay, number 9. Remember it again when we get the parent function graph for you. It's still just f of x equals x. It's that linear one through there. Something like that. Alright, now number 9, it says g of x equals 3 times f of x minus 1. So it's got to cross the y-axis at 1. So I got to take this point and drag it down to 1. So I'm looking at A, B, or C. Which one of those crosses at negative 1? Which one of those crosses at negative 1? B. So I know number 9's got to be B. That's my first answer. It's got to go through that. Now, this one says I want to take, and remember what f of x is equal to. I need to write that again. F of x is just equal to x. I want to take f of x, and I just want to multiply it by 3. So what's f of x? X. You catching that yet?
So is it
So-
always
So
really
really
all
all
you
you
do is just substitute f of x for
Mhm.
x? So where it says f of x, you just write x, like you don't give anything mathematically.
That would be the equation, 3x minus 1.
That's so much more simple than the right way to do it.
And I knew y'all just didn't understand that wording, and that's okay. We're getting it now. Everybody all right? We'll do number 10 to double check you and make sure, but they all right on that one?
I'm gonna share this on and I'm gonna forget that and I'm gonna do what I was concerned talking about, like what it did instead of proposing.
Don't do that.
Let's hope I don't do that.
All right, number 10. Now. Draw my parent function again. All right, 10. It tells me g of x is equal to negative 3 times f of x plus 1. So plus 1 means it's got to cross the y-axis at 1. Now by now, if you've gotten 8 and 9 right, you've got to get 10 right on the ABC. Which one crosses it at 1? A, so it's got to be A. Now it wants me to take f of x, which is just x, multiply it by -3. So I'm going to say g of x is -3. Instead of f of x, what's f of x the same as? X plus 1. That's it.
Number 11 is.
I didn't know. Whoa, we just finished number 10. Let's breathe for a second. I mean, I'm circling it. Number 11. Number 11 was the fun one. We'll just say that.
That's your definition of fun, I think.
All right, now, we're ready to go to 11. Hey, simmer down back there. Making Brooklyn jump. The deal on number 11 is it's a system of equations with x, y, z in a word problem. So we got to read that word problem and be able to write our 3 equations with our 3 variables. Okay? You could use, they give you types of tickets, reserve, field level, and box. So you could use an R, F, and a B if you wanted to. I want to show you the way I worked it. I didn't do that. I let X be my reserved seats. I let Y be my field level seats. And I let Z be my box seats. And I got that information from reading the problem. Those are the 3 types of tickets that the baseball stadium was selling. Okay, now it tells me, you've got to read the problem. It tells me first off that out of those 3 types of tickets, I'm buying 10 total tickets. Do you see that? So I should be able to say my reserve plus my field plus my box seats are 10 total tickets. Okay? Right? That's not too deep. Everybody got that? Then it goes on and gives me some dollar amounts. It tells me how much each of those cost and what I spent on the ticket. So I'm going to write an equation with that. It tells me that reserve tickets are $20 each. So $20 for my reserve tickets. It tells me field level seats are $50 each. So $50 for my field level. Box seats, the big money tickets, it says are $100 each. And then my total amount on these 10 tickets that I spent, $370. Okay? Everybody okay on that? Now the tricky part to me came on writing my 3rd equation. The last, next to the last sentence that it says there, says you have twice as many reserve tickets as field level tickets. So I'm looking at my Y and my X. That's my reserve and my field level. And I wrote it backwards the first time because my brain always struggles on that sentence. Twice as many, where'd it go? Let me read it right. Twice as many reserve tickets as field level tickets. Okay, so my reserved tickets equals 2 times my field level tickets. Right? See that? That was where I got confused at first. I had to play with it and make sure I had it written the right way. Okay, so that 3rd equation does not have any box seats in it, right? So if I could take my first 2 and also get rid of my box seats, I'd be able to get somewhere, get rid of my Z's on my first 2. So I got 100Z on this one. So what do I need to multiply my first one by? 100. So that's going to make 100X plus 100Y plus 100Z equals 1,000. And then my other one, I got 20X plus 50Y plus 100Z equals 370. Then my 100Z's are same sign, so I'm going to subtract. So that gets me 80X plus 50Y. Those are gone. What's 1,000 minus 370? 630. Okay. Now, this next step, we haven't done this directly. We've kind of went about it in a weird way. I would normally say new equation number 1, don't lose it. But this one, remember, does not have a Z. And it doesn't say X equals a number, but it is solved for X.
You just subtract the Y.
Not exactly. What I'm going to do, since this is what X is, normally if we have just like X equals 2, we'd plug a 2 in here, right? We're going to do the same
Oh,
thing
you're
with the
plugging in
2y. Okay, we're going to substitute 2y in for that x, because x is 2y. So 2y can go in for that x. So that's going to make 80 times 2y plus 50y equals 630. Okay, then you know 80 times 2 is 160, so you've got 160y plus 50y equals 630. What's 160 plus 50? 210y equals 630. What do I do to solve for y?
Divide by 210.
Divide by 210. So y is 3. So y stood for our field level seats. So we bought 3 field level seats. Now, go back to that tricky equation, that short one with no z, and plug that in.
2 times 3 is 6.
X equals 2 times 3. So we bought 6, what were those? Reserve seats. Now you could plug both of those back in one of your original ones, but you ought to just know how many box seats you bought. How many total tickets did I buy? 10. Now, right there's 9, right? So what does that leave for box seats? Bought 1 box seat. So we've got X, Y, Z. Interesting problem. I liked it.
Oh, I hate it.
Me too.
What'd you got, Gracie?
I didn't solve it with equations. I just plugged in numbers
Yes.
until I found it.
And that's certainly an option when you know your total like that and you know how much they each cost. You can just do some trial and error and keep working it until you can figure that out common sense. That will work. Yes. All right, flip the page.
Oh, this is where you describe the transformation.
Yes.
Like I was doing on Thursday.
Yes.
And I'm not even
Alright, on number 12, it says graph the function and its parent function. Number 12, we had f of x equals 2x squared. Okay, that's squared. This is back to week 1. Since that's squared, I got to know which family that's in, and it's quadratic. Y'all remember that? Parent function of a quadratic is a parabola, which looks like a U. Very good. It went through, let's see, it went through something like that. It needs to be more of a U shape. I can't draw on this thing.
Oh, that's the
Oh, are
parent
they
function.
Yes, this is the parent function. That's the parent function. Okay, that is just, and I'll put a G on it since that is just G equals x squared. Okay, now the one that we graph here, 2x squared, if I looked at that, remember we made one of these tables? Left off a negative one. I'll just squeeze that in there. When I square, just my parent function, when I square those, that would be -2 squared, -1 squared, 0 squared, 1 squared, 2 squared. But now this one, we'll make another column on this. This one wants me to square them and multiply them by 2. So that takes this to 8, this to 2, to 0, to 2, to 8, right? So what you should see on that is my y's, they were increased. I got a number in front of the x, which means it was a vertical stretch. This is what you were describing, what Macy was talking about. Vertical stretch, and we multiplied them by 2, so it was by 2. So that means that this, when I go 0, 0 will still be there. When I go right 2, that will be all the way up to 8, which is somewhere up in that area. And then my -1, 2 be there, so it would just be looking more like, can't draw on this thing, looking more like that. We vertically stretched it by 2. When there's something out in front of your x like that, it's a shrink or a stretch. Greater than 1, it's a stretch. Less than 1, it's a shrink. Remember that? Alright. 13 was a linear one, so it was a little more simple. parent function of a line, we did that on the previous pages a few times. Just look like that. There's your parent function of a line. That is just g of x equals x. The one that they gave me, f of x equals negative x plus 6. Okay, so two things happen on this one. It's got a negative out in front of the x, so that is a reflection on the x-axis.
Wait, why is it a reflection?
Because it's got a negative in front of the x. And then it is translated, this plus 6 means up 6. Okay, so what that would look like, took this point here up 6, so I'm going to count by twos, 2, 4, 6, and then it was reflected, it was flipped, so it would be coming the other way. So it looks something like that. Doesn't have to be perfectly precise. Okay. Reflected on the x-axis, translated 6 units up. I'm more concerned with you being able to describe that than I am your picture looking pretty.
Yeah, how would you draw that?
What's your, say the baby word for reflection.
You flip it, but I
So-
don't know how to even know to draw it.
So if I were to flip a line, what's it going to, it's just going to turn it, slope its opposite. Right? So this line here, kind of like, would be flipped. So this one would come over here and this one would come up here. That's why it's, yes, and then you drag it up, scoot it up. Alright, on the last out of that section, we're going to have to not work every one of them after this one, just do one out of each section maybe. It's got f of x equals negative 3 times absolute value of x. Your parent function on that, g of x just equals absolute value of x. Remember, an absolute value makes a v, so you would just be looking like that, right? Alright, this has got a negative, which tells us that it is reflected. Reflected in the x-axis. And then it's got a 3, which tells me it's got another number out there, which tells me I'm going to be stretching by a factor of 3.
Is it vertical stretch? Okay,
Yes.
why don't you ever flip over the y-axis? What would that look like?
It would have to be, the negative would have to be inside, in with the x. So the graph on that, it's going to be an upside down, and it's going to be a little bit skinnier because it's reaching down faster.
Wait, is it a vertical stretch?
Yes. Remember, it goes up and down, so you're going down longer.
So if that was like -1, like instead of -3, it'd be a shrink.
No, it would have to be fraction or decimal to get it to be a shrink.
But with horizontal, it's negative, and it's less than 1, right? I hope it is because there was one that was like.
I don't know. Hold on. All right, let's keep chugging here on 15. It's a pretty easy one. Table shows the height of the football over time after it's been kicked. You know, the football starts on the ground, it's being kicked, it goes up, and then it comes back down. Okay, that's making your parabola. Okay, so that was the first question that it asked you, is what function would model that? That would be a quadratic. Parabola is a quadratic. Then it wants to know how far it would go after 8 seconds. Well, the table takes you to 5 seconds. And you see at 4 seconds, it hits its max height. It's at 115 there, because then on both sides of it, it's lower. 108, 108. And that parabola has to be symmetric. So the 6th second would be 87 feet, right? And then the 7th second would be 52 feet. It wants to know 8 seconds, that would be the next one, you're 3 feet.
How do you find out what it's called, right?
Yeah.
Like, if that was on the test, I wouldn't have been able to figure
That
out.
is nothing but complete common sense. You've got to know that when a ball goes up, it comes down. Okay? You may use your notes on the test, which includes your study guide. So if you've got notes and study guide, you'll be able to use both of those. Okay? Say that again.